Hello everyone, in this video let us solve this question. So we have minus 3 raised to power n is equal to 3, and here we to solve for the value of n. So n is the unknown we have to solve for. To solve this solution, we have in bracket minus 3 all raised to power n is equal to 3. So we can express minus 3 as minus 1 times 3. So we can write this down instead of minus 3 as in brackets minus 1 times 3 all raised to power n is equal to 3. Now at this junction we are going to apply a trick. Instead of minus 1 we can write it as something else. And what is that? You see, we can express I is equal to root minus 1, such that if we square the both sides of the equation, I squared is equal to, in brackets, square root of minus 1 all squared. What we have is this, that I squared is equal to, square will cancel square root, we have minus 1. So with this, the value of minus 1 is equal to I squared. So we'll bring in minus 1 as I squared in this equation. This becomes, in brackets, minus 1 as I squared times 3 all raised to power n is equal to 3. Now at this junction, we are going to introduce logarithm to this equation. So we have logarithm of, in brackets, I squared times 3 all raised to power n is equal to logarithm of 3. Now with this, we are then going to apply rule of logarithm, and the rule is this, that if you have logarithm of a raised to power b, this equals b times logarithm of a. Applying this rule right here, what we then have is n times logarithm of I squared times 3 is equal to log 3. So from here, to then simplify this further, also applying this rule, that if you have logarithm of a times b, this equals log a plus log b. Applying this right here, all we have is n times logarithm of I squared, then plus logarithm of 3 is all equal to log 3. Now at this junction, to then solve for n, we are simply going to divide both sides by log I squared plus log 3. So divide by log I squared plus log 3. On doing this, this cancels this. We have that the value of n is equal to logarithm of 3 all over log I squared plus log 3. So from here, we can also apply this rule of logarithm, that if you have logarithm of a raised to power b, this equals b times logarithm of a. Applying this right here, what we have as the value of n is then equal to log 3, then divided by square becomes 2 times log I, then we have plus log 3, such that with this is the final value for the solution of n. Now this is the solution of n for the first method. For the second method, we can also solve this question this way. The question, which is minus 3 all raised to power n is equal to 3, can also be solved this way. First, express minus 3 as minus 1 times 3 all raised to power n equals 3, such that we can then apply this rule of indices, that if you have, in brackets, a times b all raised to power c, this equals a raised to power c times b raised to power c. Applying this right here, what we have is minus 1 all raised to power n times 3 raised to power n is equal to 3. Now at this junction, for us to solve this further, we are going to apply a principle called the Euler's identity. And this, if you have I raised to power I times pi plus 1, this is equal to 0, such that if you move plus 1 over to this side, e raised to power I times pi is equal to minus 1. So right here, we can replace minus 1 write minus 1 as e raised to power I times pi. This then becomes minus 1 as e raised to power I times pi, then all power of n times 3 raised to power n is equal to 3. So therefore, from here, and we open the bracket, what we have is e raised to power I times pi n, then times 3 raised to power n. All of this is equal to 3. Now at this junction, we are then going to introduce natural logarithm to this equation. So this becomes ln in brackets e raised to power I times pi n, then times 3 raised to power n, all is equal to ln 3. Such that once we have this, we can then apply this rule of logarithm, that if you have a logarithm of a times b, this equals logarithm of a plus log b. Good. So we can apply this right here. Don't forget that we can apply the property of logarithm to natural logarithm, such that this then becomes, we have it as ln e raised to power I times pi n, then plus ln 3n is equal to ln 3. Now at this junction, also applying this rule of natural logarithm, that if you have logarithm of a raised to power b is equals b times logarithm of a. Applying this right here and here also, what we have is this, that I pi n, which is the power, so we have I pi n, then times we have ln e, so multiplied by ln e, okay, plus power n, okay, becomes n, then multiplied by ln 3, so multiplied by ln 3, all is equal to, we have ln 3, so all is equal to ln 3. So with this, the value of ln e is equal to 1, such that this then becomes I times pi n times 1 plus n multiplied by ln 3, okay, is equal to ln 3. So at this junction, I times pi n times 1 is I pi n plus n times ln 3 is n ln 3, okay, which equals ln 3. So if you look at this, we have a common factor, which is n. Factorize out n, what we have is n into brackets I times pi plus ln 3 is equal to ln 3. Such that to then solve for n, simply divide both sides by I times pi plus ln 3 over I times pi plus ln 3. This divide this, what we then have as the value of n is then equal to ln 3 all over I times pi plus ln 3. With this, we have gotten the final solution for the value of n with the second method. So I hope you all enjoyed the video. Don't forget to like this video, subscribe to this channel. Thanks for watching. See you in the next video. Bye.